So in this video I'm going to discuss about the next topic, that is orthographic projections. So what is meant by orthographic projections? Here if you look at a diagram that is given in the sheet, this is the diagram which is in the form of three-dimensional. That means you can see its depth, its length and its height. So if you want to convert this three-dimensional into two-dimensional, then the two-dimensional representation is known as orthographic projections. So for this particular solid block, so this x direction represents the front view, and if you see from this side, the view which you are going to get is left side view, and if you see from this side, if the view you are going to get is right side view, and if you see from the top, then that is called as top view. Okay, so front view, left side view, right side view and top view. In orthographic projections, we can draw this front view, side views, top views in two ways. That is, one is first angle projection and next one is third angle projection. So first angle projection, front view will be lying above reference line and top view will be lying below reference line. And for the left side of front view, you will be having right side view, and for the right side of front view, you will be having left side view. So this is how you have to draw in case of first angle projection. And if you see the third angle projection, top view will be lying above reference line and front view will be lying below xy line, that is reference line, and left side view will be lying left side of front view and right side view will be lying right side of front view. So in the exam, if he mentions to draw the front view, top view, side views with third angle, you have to draw this. If he has not mentioned anything, by default you have to draw the first angle projection. Okay, so for this particular diagram, let us see how to draw front view, top view and side views. Okay, so before going to that, first let us draw a reference line. So in the exam point of view, remember that you will ask to draw any three views, either front view, top view or left side view, or front view, top view or right side view. So in general he will ask front view and top view, either this one or this one you have to draw. No need to draw four views, or the exam question will be in the exam question will be asked like this: either you have to draw these three or you have to draw these three. Okay, now this is the reference line I have drawn here, and I'm going to draw with the help of first angle projection. So first angle projection, front view will be above, top view is below, and this is right side view and this is left side view. Okay, so here this x indicates the front view. If for example, if this x direction is not given, then how to consider the front view? Remember, if this x direction is not given, take the longest length as a front view. Okay, longest length as front view. For example, if this is not given, here 104 is given, so take 104 as front view. For example, if this 104 is this side, so you have to consider this side as the front view direction. Okay, now look at this diagram. This is the diagram number 2034 from ND textbook. Okay, I have taken the diagram from there. Now from the front view, what are the portions you can see? Let us observe. So if you see from front view, so this is the shape. You can see this portion and this portion and this portion. So I'm marking like this. This you can see this one, and you can see this one. So 1, 2, 3, only these three parts are visible in the front view, and this 24 and this portion is the top surface that is not visible in the front view, and this is also not visible. This portion is also not visible in the front view. Just like this, if you take an eraser, this is the three-dimensional view. In the three-dimensional view, you can see its length, height and depth. If you see, this is the front view. In the front view you can only see this portion. You cannot see the top, you cannot see the left, or you cannot see the right. Only front view will be visible. In the same manner here also, this portion is visible, this portion and this portion is visible for you. So let us draw. So this is given as 104 and this height is how much? He has given as, this is 48. So 104, 48. So I am drawing a rough sketch, not taking exact dimensions. So because I am drawing in the A4 sheet, space is very less here. I am taking some rough dimensions. So let this be 104 and this height is your wish. You can take a 10 mm or 20 mm from the XY line or reference line. And this height is how much? 48, like this. So I have drawn this portion, and what is this distance? This is given as 24. So let us be like this. And how to identify this height? You can see the total height is 48. Out of 48, this step length is 16 and this step length is 16. 16 plus 16, 32. So this will be 32. And you can extend this up to here. And you can join. So this portion is completed. And next one you have to draw this step length. So this height is 16 and this you can join directly up to here. So take 16 height and join like this. And next one also, this is also 16, extend up to here. So this is how you are going to get the front view of the particular diagram given here. Okay, so this part is this one and this one is this portion and this portion is this one. So you have to give some dimensions. Dimensions are mandatory. So you can mention this height here. So this is, you can give with the help of armor 48, and we can mention this length. This is 104. And you can also give some more lengths. This is 16, 16. And no need of mentioning this height because this total height is 48. Out of 48, if you subtract 16 plus 16, 32, and remaining will be 16. Okay, so this is the front view. Now for getting the top view, draw the projections like this. Okay, I have drawn two projection lines. Now in the top view, what is the portion you can see? If you see from the top side, you can see this area. Okay, this portion and this portion. So like this one and this one, and the distance from here to here is the same. It is equal to 104. And the distance from here to here, how to find it out? So out of 104, if you subtract this one, we'll get this portion. So 104 minus 24, you get this distance. This is 80. Okay, and this length is 24. So 80, 24. This is 80, 24. These two steps you will get, and this distance is 104 and this is 72. That is how you have to draw. Okay, so this will be 104 because this distance is 104. I have already mentioned, and 104. And what is this distance? That is 72. So like this I have taken. And what is the step length? 24. and this one. So first I am drawing this one like this. So you know this height out of 72, 24, 24, 48 is subtracted. So this distance will be 48, and I am extending this up to here. Close it. Next. So this is 24 and this is 24. From here, mark it as 24, 24, and you can draw two steps in the top view. So this is 24, this is 24. Okay. So in the top view also you have to give some dimensions. This is 72, and this is 24, and this is 72, like this. So we have completed the front view and top view. Now we have to draw this left side view and right side. First I am going to draw this left side view, because in this diagram I can see the left side very clearly. So in the left side view, what are the parts you are going to see here is, so this is the portion which you can see in the left side view, and this is the portion, right? In order to get this one, we can directly take the position from the front view and top view. Okay, so you can draw the positions from here like this. And from here you can draw 45 degrees line. So this you can draw like this. So from here you have to draw 45 degrees line, so that you can get the this portion is left side view. So here in the left side view we have this step lengths, so you can project this step lengths so that you can identify easily. And from the top view, if you project these two step lengths with an inclination like this, so you can see it is in the form of the small boxes, but actual shape is we have to get this. Okay, so like this. So I'm darkening with the help with a free hand. So this portion which I have mentioned here is this one, this part. And what about this portion? That is this one. So like this you can easily plot the left side view. So if any missing dimensions in the front view and top view, we can plot here. And this 16 is here, 24 we have already plotted here, and this height is 16 we have already plotted here. No need of plotting any dimensions there. And one more dimension we are missing is this is 24, means this height is 24. So you can mark it here. This is 24. Okay, next, in the same manner you can also draw the left side view. So what do you think the right side view will be if you see from this side? From this side, how the shape will be? Here, that is a total rectangular block. But remember that in case of projections, you have to show the hidden lines. Means if you see from this side, you cannot see all these edges, or this edge, this edge, this edge. So we cannot see. Even though we cannot see, we have to plot that invisible edges with the help of dotted line. As you already know about that. Okay, so if you project this side with the help of 45 degrees line, you are going to get the box. Okay, and like this. And here you no need to take 45 degrees. With the help of compass, you can draw the arc. So here I have done 45 degrees I have projected. We have one more option. If you take this center, this point as center, where the projection line and XY line meets, and from here to here as radius, you can draw with the help of compass. You can draw arcs like this. I am doing here with the help of freehand, but you have to use compulsory compass. So for 1 2 3 4, this is the center, and you can project like this. But you know that in the right side view, you can see only a rectangular shaped box. You can see only a rectangular shape. But if you see from this side, all these edges are not visible. Even though they are not visible, we have to plot with the help of straight lines, dotted lines. So just draw this projections with the 2H pencil. Next, see, from here to here we don't have any edges, and this portion is edge. So after this distance, this is the first edge you can have, and after coming downwards, this is the edge we have, and after this one, this is the edge we have, and after this one, this is the edge we have. Now this is how the right side view look likes. And this is the solution for first angle projection. If it is third angle, you can see the top view will be upwards, front view will be downwards, left side view will be left side of front view, and right side view will be right side of front view. Means this diagram will be going upwards, this will be coming downwards, and this is coming to here, and this is coming to here. Procedure is same, but the position of the diagrams will change in case of first angle and third angle positions. Okay, and one thing, if you observe one more thing, the left side view and right side view are looking like mirror images. See, here this is like this and this is like this, but the only thing is from left side these edges are visible, and from right side the edges are invisible. That is the reason we have to mark this with the help of dotted lines. Okay, so this is how we have to solve the problem in case of first angle projection. And remember, this is the problem number 2034 in ND BERT. In the next video, I am going to come with one more problem. Thank you.